This is Ham College, episode 18 for June 30th, 2016. This episode of Ham College is brought to you by ICOM, reminding you Field Day is June 25th and 26th, and by hamstudy.org, a great place to study for your amateur license exam. Hi, welcome to another episode of Ham College. I'm George.
I'm Tommy.
And this is a show where, currently we're helping you study for your technician exam.
Absolutely. No Professor Thomas and Dean Martin this time, huh?
Well, we could have done that. We had skipped at least 1 month.
We skipped last month. It's okay.
It's okay. Well, I guess the first thing that we want to do is tell you that whenever we're doing this show, we've got a chat room going live, AmateurLogic.TV/chat. And as a matter of fact, this chat room's been going for a couple of hours, and so have I, while we were waiting on your plane.
I'm close to 3 hours late, so.
Yeah.
But there's still people in the chat room there, so
there is.
Come join them.
Yep. What did we talk about last month?
We talked about some digital modes, voice over IP type stuff, Echo Link, things like that.
We did. We don't have a picture of that.
But you can take my word for it, it was there.
That's what we talked about. Yeah. And what are we going to talk about this time?
We had so much fun last time, let's do some more modes. Not digital modes, just other modes.
Why don't we look at a real radio this time?
That sounds good.
Some people
one kind of like this.
Something kind of like this. Some people would say this is not a real radio because it's a software-defined radio. But
well, it looks like a real radio to me. It's got knobs.
Actually, you know, we used we had 3 of these for Field Day.
Yeah.
And they performed like real radios to me.
Yeah, it performed very nicely.
They did. Boy, what a nice rig for Field Day.
Yeah, it's performed so nice, Ray may have a hard time getting some of them back.
He could. We've got, another few thousand feet of that crime scene tape back there if he comes around.
Yeah, he's been going to the gym, though. I may have to put a few extra wraps around him.
This is an HF radio. When you get a technician's license, you're going to be getting privileges for VHF and UHF. You'll also get some limited HF privileges, but that's going to be for operating CW, not the voice modes. Except 10 meters.
For 10 meters. You got just a very small slice. And if you go look back at the archive on the Ham College shows, we did cover all those privileges.
Now this radio here is a ICOM IC7300. It's a brand new model.
Yep.
If you're getting your technician license, this is probably not your first radio because it doesn't have VHF and UHF on it.
Technician, it wouldn't be a great idea for your first one.
No, because you're going to want the VHF and UHF bands.
But we can demonstrate some of.
We can demonstrate the modes on here. That we're going to talk about tonight, real easily on this radio.
Yeah.
Now this one, has got a computer display on it. It's a software-defined radio, which means there's a computer in there that actually runs a receiver, or not runs it, is the receiver and the transmitter, actually. Those are just now becoming popular. So your HF radios, some of the older ones, will look totally different than this one here. But this is what we've got handy because we were using some for Field Day, and we've still got them here right now.
And it's a real nice one to have handy.
It is a nice one to have handy. So, Tommy, what do you want to tell us about first?
Well, I thought we'd go through some of the modes. So tonight's topic is multi-modes, right? So I thought we'd we'd bring up some of the modes that we have available on this one. We've got single sideband, CW, RIDI, which we talked about before a little bit. Actually, we've talked about all these some. AM, FM, and then we've got a data mode here for doing like PSK 31, which we showed. I think it was last month or the month before.
Yeah, I think it was. So that's a good many modes there. That's not all the modes that are out there, but this is typically what you'll find
they're the most popular
on a
ones.
radio like this.
Yeah. So they've got a lot of different uses. There are different uses for each one. So CW, if you're a Morse code guy or gal.
Now CW, that stands for, what does that stand for?
What does it stand for?
Continuous
wave.
So let's look into some CW here.
Well, let's see if we can find some. We're going to have to go over to...
There's probably some on 40 meters, which is 7 megahertz.
It's going to be probably down at the lower end.
Yeah, so if you tune down around 7,000, we ought to be finding some down there.
A little noisy.
Yep. But we are in lower sideband mode right here.
We are.
Yep, because the radio switch modes when you switch bands.
Yeah, and it's smart enough to know the one that's common for here for the right band.
So you can hear CW, or what we normally call Morse code. You can hear that in sideband.
Right. I think it's because that's the mode we had when we used the radio before, but we can change that to CW by going there.
Now we don't hear it anymore, and there you go.
So we got a lot cleaner CW tone.
Yep. It cut out all that noise.
So okay, that's pretty cool.
So that's CW. I wonder if you could hear it on an AM. Yeah, you can hear it there too. You can hear it. CW is just going to give you a sharper.
So let's talk about what we're hearing on CW. It's changing the way we're listening to the modulation, but it's also changing the bandwidth of the receiver. So the CW bandwidth is a lot more narrow than sideband, which is a lot more narrow than AM.
And that means really two things, doesn't it?
Well, it does. One of the things it means is you're not going to hear a lot of the adjacent noise with your signal. So when we flipped over to AM, and you hear all that white noise in there with it, that's because we got a lot more spectrum outside of where the actual CW is. And what else?
But what else it means is, since we're taking all our power and concentrating it into one little bitty narrow band, that signal is going to go further.
Yeah.
Because the power is concentrated right there in a little narrow bandwidth. So that's the advantage CW's got. It's going to go farther. You don't have to learn it anymore. You don't have to learn Morse code to get your license for any class.
Right. And I didn't for mine.
I didn't either. But there are a lot of people that are using it and are still learning it today.
Yeah, and I'll be honest with you, I actually have more desire to learn it now than I did before when they were like forced to. I just don't have really time right now to do that. But
one thing
I would like to learn it.
I wish we could see on here, and it's going to be difficult to see, but if you looked right there really hard, if we could zoom in on that, you would.
We can touch it.
Then look right here. You're seeing the dots and the dashes.
It'll freeze it and makes it just a little bit bigger.
Yeah. Well, we are actually seeing the dots and the dashes of that CW signal right there. Here's another one here, and you can see in the waterfall display. You can see as they're turning the carrier on and off.
That's pretty cool.
Yep.
I really love the display on this thing.
I do too. All right, so that's CW mode. What mode do you want to talk about next?
Let's talk about, that was the most narrow. So now let's go up a little bit to single sideband.
Tell you what, let's talk about AM first.
Okay.
I think that might be a better progression. All right, so we'll have to find us an AM signal here. Just go where we were a while ago, 5085. That is a WTWW 5085.
5 megahertz?
Yeah.
Oh.
You can just, well, here, you can just get there really quick doing it that way.
You can still listen to every minute of the Dark Matter Radio Network by calling 605-562-4444. No smartphone, app, or internet.
Let's spread it out a little more on the display here. There's 10 kilohertz of bandwidth. This is a shortwave station that we're hearing here. Mm-hmm. We can see 10 kilohertz reaches from, well, here's the center frequency. This is minus 10, this is plus 10. So that signal is going out to almost 8 kilohertz wide.
Oh, wow.
If we expand it a little more, now we can, now we're looking at 50 kilohertz worth of bandwidth here. That gives us a better idea where that signal's sitting. If you'll notice right there in the very center of it, there's that.
Thank you.
Oh, yeah. We're not big on Dancing Queen now.
No.
If you'll notice that little solid line that's going there in the center, that is the carrier. That is the AM signal. If ABBA would stop singing, we would not see this stuff on either side. All we would see is that little line there.
Okay.
What we're seeing, the carrier and the stuff on the sides here is the two side bands for an AM signal. This is the lower side band. This is the upper side band. So AM is using that much space. In other words, we've got the signal we're listening to here this wide. That's the carrier, that's the modulation.
Okay, so if I remember right, last month we said that AM was approximately 6.
It can be. It can vary in the bandwidth.
And sideband was about 3.
Yeah, and that's what it said and what we were looking at. But it can actually, it can be variable bandwidths. But you're right, AM is going to be twice as much as sideband.
Of course, this is not a handbrake that's transmitting this either.
No, but let's just look at it here. We're listening to both these sidebands together. If we go to sideband, now we're here in the lower sideband. We're actually only listening to this half of the signal. The upper sideband half up here, we're not hearing. Let's get a better look at that. Find us a signal in somewhere in the 40 meter or 80 meter band there. So there you go right there. That's a good example of a sideband signal.
Yeah.
You can see our radio is tuned to this frequency, but there's no modulation on the upper sideband here. It's all on the
lower. You can clearly see it all bunched on the left.
Mm-hmm.
That's pretty interesting.
Yeah, you don't have this kind of display on a regular radio. I mean, it's this is called a pan adapter or a spectrum scope. At the top here, the bottom part is called a histogram or waterfall.
Right. Yeah, but most you won't have it on the 2 meter.
No, you won't
70 centimeter rig, but it is good to demonstrate the point.
Yeah, it helps to demonstrate the point we're talking about. So with the sideband signal, either lower or upper sideband, we're only listening to where either below or above where we're tuned.
Okay.
All right. So, well, there's. All right. Let's put it on upper sideband. That signal is still there, but we're not hearing anything.
Yeah.
Because we're listening on this side.
We're listening to the wrong side.
Yep.
Pretty neat stuff.
Now he's back. Pretty neat stuff.
Yeah. So let's. So what are the benefits of one or the other? We talked about the benefit of CW.
Yep. Because it was narrow band, so we didn't have to hear a bunch of extra noise, and the signal goes further.
Yeah. Well, okay. Sideband. Similar characteristics.
Yeah, it's about half as wide as AM.
Yeah, so you probably wouldn't get quite the distance.
Well, on AM.
Yeah.
On,
Yeah, actually on AM, yeah, you wouldn't get quite the distance on AM as you would on sideband.
right.
But also the power limits are different on because, well, actually, most of the rigs are. I guess that's not a legal requirement,
Yeah.
though. But most of the rigs are like 25 watts
Well,
for
there's
AM and then 100 watts for sideband.
there's a good reason for that, and probably a little more technical than we should get into, but I think I will anyway.
I figured you would.
Yeah. you open that door up,
Yeah, that's
but on the sideband there, so we're only, you know, if we're doing sideband, we're only like using half of the bandwidth. If we were on AM, this would be, you know, extending above and below the frequency we're on. We're only using lower sideband here, so our signal is all concentrated in that narrower bandwidth. So it's only half as wide. The signal's going to take up less bandwidth, so we can get more conversations going on a band. But one other thing it's going to mean.
well, it's going to go farther, like we
Yep.
said earlier. It's like putting your finger over into the water hose.
Yep. It's going to squirt that water out there
Squirt
first.
it out farther.
Yep. That's a good analogy. I've
Yeah,
never.
that's the best one I could think of.
That was pretty quick too.
Short notice like
Yeah.
that.
Yeah. So there was something else I was going to say about that, and it totally
The whole water
evades
hose
me
thing
now.
just washed it away.
that just
didn't
kind of washed it away. So there's one other thing here. There's no carrier. You know, on AM, while when there's no modulation, you still got that little line there in the middle, that carrier frequency going. Here, that's suppressed. You don't have it. All you've got is that lower half or the upper half.
it? Right. And if you had a watt meter hooked up, then if you're on sideband and you key the mic up, you're not going to see any output power unless
Right.
you have some audio,
Right.
some modulation.
If we go to, well, let's just look at that. We can. We don't have a mic plugged on, but we can push this button and transmit.
yeah.
There's nothing at all there because we have no modulation, so we have no carrier or sidebands.
Right.
If we did have a mic there, we would have a sideband then, but we still wouldn't have a carrier because there's no carrier on single sideband.
So for the technician operator, what does this mean for them? It means that it's fun to play with the other modes. But you're probably going to be on FM mostly.
You're mostly going to be on FM because most of those radios are going to be FM.
But if you got a few buddies that's a couple hundred miles away, then
with single sideband
and
rig,
they both have single sideband
Yep.
rigs, that there's a real good chance you could talk to them
a much better
fairly
chance.
frequently.
Yeah, you're going to talk farther on single sideband, but it's not as popular. So
Yeah.
Another thing is on VHF and UHF, and this has nothing to do with the questions today, but if you're running FM, typically your antennas are going to be vertically polarized. They're going to be up and down. The people who are on sideband are running horizontal polarized antennas.
Yeah,
know.
pretty typically.
And so, those two don't coexist. Well, one doesn't hear the other very well.
Right.
So, and the reason they're running horizontal for sideband, I don't know. I mean, I'm sure
I
there's
don't know
a
why they're
reason,
doing it either, but
it's just something to keep in mind that if you've got a rig that does VHF and it does FM and single sideband, that same antenna is not going to work good both ways. You're going to need one of each polarity there to get the most out of it.
And one of my first HF rig was pretty much all modes, all bands, and I was so excited about that sideband stuff, and I never talked to a soul on it. It's just not very popular. Of course, I didn't have the right antenna to hear them either, so. But I'm sure there are a lot of people on it. I hear people talking like from Jackson to Memphis.
Well,
then that's a couple hundred miles or so.
And these people who are doing contesting on VHF and UHF, they're all running sideband. They're not, or some other mode. They're not running FM for those contests.
Yeah, and my 7100 I got at the house will do 2
Yeah.
meters sideband or 70 centimeters or whatever. So. But
Any other modes here that you want to talk about tonight?
well, I think that's the most popular ones. We got FM.
Yeah, and I don't know that we've got an FM signal we can pick up, unfortunately.
Yeah, and you probably don't want to use FM on HF either. I don't.
You can.
I know you can, but I've never really heard anybody do it.
We've played with it some.
Really?
And, yeah. I mean, it's on an HF rig here, so
Yeah.
somebody's using it. Normally, you probably use it up on 6 meters.
That's what I'm saying. I'm assuming that's primarily used on 6
Yeah.
meters.
What you would see on FM here, if you were looking at a signal, you would see the carrier right there, and you might see a little bit of sideband on either side, but you won't see that modulation dancing up and down like that.
Mm-hmm.
What you would see, if you zoomed in real close, you'd see that carrier shifting frequency a little bit back and forth. It's frequency modulated. So that's how you're getting the information across. You're varying the frequency rather than the amplitude of the signal.
And what's the bandwidth for that?
I'm not sure what typical ham FM bandwidths would be. It's going to be different because it's primarily, VHF and UHF. That's where we've got that. And there's both what we call wideband, which are the older radios, and some of the newer ones they're narrowband FM. Hams are generally staying with the wider bandwidth stuff, but most of the commercial stuff has all gone to narrower bandwidth now, so they can get more channels than that.
And I would assume it's less bandwidth than AM.
Yeah.
I'm not sure. I would assume it is.
No, I don't know. I really don't know. I have to look that
Yeah, we'll
up.
have to check that and report back. But there's a lot of bands. I mean, a lot of modes and a lot of bands actually, and a lot of fun there.
So there's just a quick description of some of the different modes that you can do on a radio. There's more modes than that. That's just the basic ones right there.
Ones that are built into most radios.
Yep. Well, Tommy, what do you say we take a quick break and then we come back and we give away something?
Sounds like a good plan.
Calling all stations. The most popular on-air event is here. Field Day, June 25th and 26th. Make sure your ICOM equipment is ready for action. Limited space? No problem. The IC7100 base station is a great compact D-Star option. Angled control head and touchscreen for quick intuitive operation, large internal speaker for clear digital audio, and it's perfect for multi-bands and all-mode communications. Be one of the first to experience how ICOM is changing the way receivers are being designed with ICOM's new IC7300. It will exceed expectations. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The sky's no limit with IC9100, the versatile all-around transceiver, multi-band, multi-mode, independent dual receivers, satellite mode operation, optional D-Star DV mode with the UT121, and USB connector for PC control. Visit ICOMAmerica.com/amateur for more information on ICOM's radios. Field Day was this past weekend, and we had a big time, didn't we?
Yeah, it's pretty warm.
It was pretty warm.
It was fun though. Had a great time. But you know what, man? The shower after Field Day, the post Field Day shower, that's like the best shower you can ever have.
Yeah, that is a pretty good shower, isn't it? All right, Tommy, we got a winner here.
All right.
What are they going to
gonna
win? Yeah.
Hey,
You could
I
have
got some of this stuff here we can give away.
Yeah.
It's a lot like the ones we gave away last month. A nice ICOM hat and a nice ICOM Ham Crew t-shirt.
Yeah. Sounds good to me.
I need to win this myself because I don't have mine anymore.
You don't? Your son steal it?
I don't know who got it. It disappeared.
Yeah.
But anyway, you win this nice ICOM swag and be one of the best dressed folks at the Ham Fest.
Well, we just did a quick random drawing here. This month's winner is going to be Mike Joyce. And Mike is K1MFJ.
Oh,
Wow.
neat call sign.
Neat call sign. I better write his name down.
Congrats, Mike. You'll get this directly from ICOM here pretty quick.
All right, Tommy, I'll read the first question here and you can answer it. What is a transceiver? A type of antenna switch.
B, a unit combining the function of a transmitter and a receiver.
C, a component in a repeater which filters out unwanted interference.
Or D, a type of antenna matching network.
What do you think?
Well,
What is a transceiver?
Well, it's pretty well a dead giveaway if you read that.
Yeah.
It's not going to be D, antenna matching network.
That would be a transmatch.
Yeah.
I think that's
okay.
how
Let's break down the word transceiver. That tells me that's. I read that as transmitter and receiver combined.
I think you're onto something.
So the only one that makes any sense right there is B, Bravo, a unit combining the functions of a transmitter and a receiver, and that's my final answer.
Well, it looks like that's what they're saying over in the chat room, and that's what I'm saying.
Well, that's a wise group in the chat room, so it must be correct.
There you go.
Right. All right.
All right.
Somebody's got to get one wrong this time.
It could
I haven't had the
happen.
buzzer sound in a couple months.
I'm not sure we've had the buzzer sound for quite a while.
Yeah, it's been many months.
Yeah. All right.
Which of the following devices is most useful for VHF weak signal communication? A quarter wave vertical antenna.
B, a multi-mode VHF transceiver.
C, an omnidirectional antenna.
Or D, a mobile VHF FM transceiver. And this one's mine to answer.
That is yours.
Well, you know, I think we've already kind of, and not intending to necessarily, but kind of told you the answer to this one when we were talking about the radio.
Yeah. That's not the first time that's happened.
So what is the most useful for VHF weak signal communications? Well, you remember we were talking about contesting earlier, in that there was one mode that was kind of better for doing that. Well, CW would be the best because that's going to go the furthest. That's not one of our choices here. So let's see, a quarter wave vertical antenna. Well, a quarter wave vertical antenna is not a particularly strong antenna.
It's not that good of an antenna.
No. So I don't think that's necessarily what you want. Let's see, D, a mobile VHF FM transceiver. Well, you know, FM is the most popular on VHF, but, you know, the FM is not the best mode for weak signals.
Yeah.
C, an omnidirectional antenna. That means it's an antenna that's going to pick up signals equally well from all the way around. No, I don't see where that would be useful for a weak signal, because I'm not zeroing in on any particular direction. I'm just picking up from everything, so there's no gain to that. So really, the choice is a multi-mode VHF transceiver, B. And that's because we said that single sideband was going to go further.
Yep.
But you could even use that for CW too if it's multi-mode.
Yep, absolutely.
So let's see, they're saying B and they're saying C in the chat room. And then a lot of them not saying anything, so B. I think the B's have it. Let's see. I was right, Tommy.
All right, you nailed it.
I nailed it. Well, let's see if you can nail this next one here.
Yeah.
Which type of voice mode is most often used for long-distance weak signal contacts on the VHF and UHF bands? That's a toughie, huh?
Yeah. Not really. We pretty much
We've told you the answer.
just said that one already too. But okay. Okay, well, I'll read the first one then. A, FM.
B, DRM.
C, SSB or single sideband.
Or D, PM.
Well, don't know what PM is.
That would be phase modulation,
Phase
but
mod-
that's not something that we even
Yeah.
talk about. So.
Okay. And we just said FM's not good.
Not the best, or most
Not
often
for best
for long
for
distance.
long, right. We pretty much told the answer that it's going to be C, single sideband.
Yep.
And I don't know what DRM is for option B is either.
I think that's
Digital rights management.
our digital radio mondial. That's shortwave
Oh, is it?
digital. Yeah.
Okay.
But anyway, it's I'm going to agree with you, Tom. It's going to be C.
B Charlie single sideband.
That's what they're saying over in the chat room. We know that's going to be it. There you go.
Yep, we just went through it.
Yep. All right, next.
Which of the following is a form of amplitude modulation? A, spread spectrum.
B, packet radio.
C, single sideband.
Or D, phase shift keying.
I'm glad this one's yours,
I know you are.
but this is right up your alley.
Well, let's see. Amplitude modulation. That means we're modulating the carrier. We're going this way and not this way. We're not changing the frequency, we're changing the amplitude. All right, spread spectrum. That's not it. Spread spectrum is scattering out your modulation and over a bunch of frequencies. That's not amplitude modulation. B, packet radio. No, packet radio is that's generally used on FM mode, but it doesn't really specify a modulation. It's just digital radio. D, phase shift keying. No, phase shift keying is taking that frequency and it's moving it, changing the phase of it slightly. But the one that does change the amplitude of the signal there is single sideband. It's not AM, but it's half of AM.
Yep.
Almost.
Yeah, we showed that earlier.
Yep. So it is, and I'm glad we had that radio handy. It worked out good
Yeah.
for that demo.
Sure did.
Yep. So yeah, it's going to be single sideband. That's what they're saying over in the chat room. They're saying C again.
Nailed it.
Single sideband. All right, next one. Which sideband is normally used for 10 meter HF, VHF, and UHF single sideband communications? It's A, upper sideband.
B, lower sideband.
C, suppressed sideband.
Or D, inverted sideband. Okay. I don't know inverted or suppressed sideband, so I could scratch out C and D.
Yeah, never heard of those.
B, lower sideband. That's typically like 40 meters and below. So I think the answer is going to be A, upper sideband.
You think it's going to be A? Well, that's what they're saying in the chat room.
I could be totally wrong. I honestly am not 100% sure. I don't spend a lot of time on 10 meters, but I'm pretty sure that's right.
You want to change your answer?
Do I get to call a friend? Nope, I'm not. I'm sticking with it.
Okay. You're right. And that's what they were saying over here too. And I want to say something about that. You say 40 meters and below is all that typically is lower sideband. Above 40 meters, we start using upper sideband. Now the radios will do either one.
Sure.
On any band. But yeah, lower, below 40 meters, or 40 meters and below, and upper sideband above that. You know, I had never really thought about which sideband they used on VHF and UHF. But,
Yeah, I haven't either.
But apparently it's
We
it's
must
upper
follow
sideband.
the same rule.
Now another thing that might sound a little funny there, if you haven't studied up on your meters, is we're saying 40 meters and below, and this is 10 meters. It sounds like it's below 40 meters, but it's not.
Yeah.
As you go up in frequency, the meters go down because your wavelengths are getting shorter. And when we talk about 10 meters, we're talking about the wavelength of that frequency. So enough about that. What's next?
What is the primary advantage of single sideband over FM for voice transmissions? I think we gave this away too. A.
Let me say one thing before you continue on. They brought up something important in the chat room here, and I'm glad I looked. The only exception to that rule, 40 meters and lower, is lower sideband. 60 meters is upper sideband.
Yeah.
You know, we've got just a few
just a
60
few
meter
frequencies.
frequencies.
Yeah.
Now that's not something that would come up here because technicians they don't have 60 meter privileges.
Mm-hmm.
So, but that is a good point. Yeah, upper sideband for those few channelized frequencies we have on 60 meters.
Told you that's a pretty wise group in the chat room there.
Yeah. So what were we talking about?
Well, I was asking you what's the primary advantage of single sideband over FM for voice transmissions? Is it A, SSB signals are easier to tune?
B, SSB signals are less susceptible to interference.
Or C, SSB signals have narrower bandwidth?
Or D, all of these choices are correct. Well, I think when we're talking about single sideband, that's actually harder to tune because if you're off frequency, I don't know if we've got this radio tuned on anything right now.
It's pretty cool that you can actually see somebody talking off to the side, isn't it?
Yeah. Well, I'm gonna say that's a little harder to tune.
Yep.
So I don't think the answer is not an advantage because it's easier to tune. So I don't think that's true. It certainly was hard to tune.
Mm-hmm.
A lot harder than a AM or FM signal would be. Single sideband signals are less susceptible to interference. I hear plenty of interference in there.
Yep.
I don't think that's the case. If I was listening to an FM signal, I wouldn't really be hearing all that lightning static. C, single sidebands have narrower bandwidth. That's going to be your choice because it can't be D because we've already ruled out A and B. Those are way out. So it's got to be C, and that's what we got over there in the chat room. Although we did have some D's there.
And we did touch base on that though. D's? Really?
Yeah. Yep. We did. We must have thrown them off somehow. What's the primary advantage of single sideband over FM?
The easier to tune thing kind of throws the D out to me.
Well, it does to me too. So does the less susceptible to interference. Mm-hmm. Although you would think possibly because single sideband would go further, but no. In reality, it's a narrower bandwidth. That is the correct answer for this one. And there we go. What is the approximate bandwidth of a single sideband voice signal? A, 1 kilohertz.
B, 3 kilohertz.
C, 6 kilohertz.
Or D, 15 kilohertz.
What do you think?
Well, approximate bandwidth of a single sideband voice signal is going to be Bravo 3 kilohertz.
You think that's it?
Yeah, because we talked about that last month.
We did talk about that last month. And I'm giving them a chance to catch up in the chat room. They're saying, yeah, they're going with B, Tommy.
Yeah, I can't, and I can't reason that out. It's just something you just got to know that one.
Yeah.
I don't know how to reason that one out, other than just commit it to memory.
Pretty much. I mean, 1 kilohertz. Well, if you think about audio frequencies, 1 kilohertz is a real tiny little sliver of audio. That would be kind of hard to hear. 3 kilohertz is Almost as much bandwidth as you'd have on a standard analog telephone.
About 1 kilohertz is about what CW is, isn't it?
No, it's a lot narrower than that.
Is it?
Yeah. 3 kilohertz is a little less bandwidth than a standard, old dial-up telephone would have. You could hear that okay. 6 kilohertz is twice as wide. I think if you checked your radios, you would find that most modern radios would not tune 6 kilohertz wide for a single sideband signal. And D, 15 kilohertz, that's way too wide. With sideband, we're trying to conserve the amount of bandwidth we're using a little bit. So 3 kilohertz, you were right about that, Tommy. But that's the best reasoning I can give you for it. Is, but yeah, it's 3. If it was AM, more likely 6. But one other thing I'll say is your radio does not necessarily lock on to one of these bandwidths. A lot of radios, you can vary that bandwidth. 3 is just kind of commonly accepted standard.
Interesting stuff.
Yep.
Okay, which of the following describes combining speech with an RF carrier signal? A, impedance matching.
B, oscillation.
C, modulation.
Or D, low-pass filtering. And this is mine, which the following describes combining speech with an RF carrier.
We just showed that.
Yep. So I know it's not going to be low-pass filtering because that's not combining anything. That's filtering out something. Impedance matching. I don't think that has anything to do with matching impedances.
No.
Oscillation, well, a carrier is what's produced by an oscillator. But when we put speech on that carrier, we've made modulation. We're modulating that carrier. So I'm going to say C.
That's your final answer?
That's my final answer. You think I'm right or wrong?
I think you're on the money.
I'm on the money. Yep. And, everybody over here on the old chat room was on the money on that one too.
Everybody nailed that one.
Yep. Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stuffelbein, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam.
And now, before the next show starts, let's enjoy an intermission. You'll find our snack bar chock full of good things to eat and drink. Tasty, tempting hot dogs, thirst-quenching soft drinks, fresh, crunchy popcorn, a complete assortment of delicious candy, and a full line of cigarettes. You've plenty of time, so visit the snack bar now. A tasty treat will double your enjoyment of the show.
Yes, Toddy, the chocolate malt in a can.
It's so good hot. It's so good cold.
It hits the spot with young and old.
Yes, toddy pleases everybody. Delicious chocolate malted toddy, made with rich, real milk, not powdered milk.
So come and get it, everybody. It's time to drink your chocolate toddy.
Just a minute, folks. Yes, that's all it takes to visit our refreshment counter in the lobby. There you'll find popcorn and an assortment of popular candy bars to please every taste. Try one of these delicious candy bars. Big Time, Butternut, Milkshake, Payday, topped with Hollywood's super rich coating of the kind you like best. They taste wonderful, they're delicious, they're nutritious. Get one at our confection counter in the lobby now.
And now back to our show.
Did you go to the snack bar and get you some tasty cigarettes?
No, I didn't.
Those things are pretty trippy, man.
Yeah, those are pretty wild.
I'm going to have to go get me one of those hot chocolate toddies.
Yeah, I never knew that's what a hottie toddy was.
Me either.
Well,
Those are pretty good, though.
yeah, they are. I try to pick out some different ones every time.
Yeah.
Yeah, and I know there's some repeats in there, but we still got a lot of them left that we hadn't played yet. Well, back on into our questions here. I don't even know whose turn this is. I think it's, I'm going to ask you this one. Which of the following controls could be used if the voice pitch of a single sideband signal seems too high or low? A, the AGC or limiter.
B, the bandwidth selection.
C, the tone squelch.
Or D, the receiver, RIT, or clarifier.
So what do you think?
Yeah, the AGC or limiter, that's the automatic gain control. That's not going to have anything to do with the pitch of the voice.
No.
The bandwidth selection, I don't think that's going to have much to do with the pitch of the voice
No,
either.
that won't change the pitch.
The tone squelch, that's not anything to do with the pitch of the voice. That's going to squelch the audio for with a subaudible tone until it detects one, rather. So it's got to be D, the receiver, RIT, or clarifier.
Well, I think you're right, and I think this one may take a little bit of explaining. And
Yeah, so why don't you do that? What does RIT stand for? RIT.
the receive incremental tuning.
Okay.
All right. James said over here in the chat room that, or you could use the big knob, and yeah, that would be the first thing I would grab for, but that's not one of the choices they gave us.
Yeah, it should be there.
What's actually, well, let's just see if you're right. And you are. We knew that you'd be right on that. What's actually happening when you change the RIT, and some brand of radios call it the clarifier. What they're actually doing is just shifting the frequency of the receiver a little bit. You could do the same thing by turning that big VFO knob on your radio. But when you turn it, you're changing the receive and the transmit frequency. So that means if you are, say you're listening to a net and everybody on there sounds right, but this one guy is really high pitched. If you tune your VFO knob to where you're hearing him correctly, then when you transmit, you're going to be off frequency to everybody else.
Right.
If you change the RIT or the clarifier, you're only changing the frequency of your receiver and not your transmitter. So that's the answer for that. And a little, maybe a little complicated if you just didn't know that, you hadn't worked with a radio that had that.
Yeah.
So that's the answer on that one.
Uh-oh.
Yeah, well, I think I hear echo in here.
Yeah, you can tell I haven't went through and read the question pool, so there was no cheating here.
Yeah.
What does the term RIT or RIT mean? A, receiver input tone.
B, receive incremental tone.
Or tuning.
B, receiver incremental tuning.
C, rectifier inverter test.
Or D, remote input transmitter. And this is mine to answer, and
Again.
and I told you what it was a while ago. It was receive incremental tuning, B.
Yeah. They really can't, nothing else you can really say about that.
Nope, that's just what it is. Which of the following is the appropriate receive filter bandwidth to select in order to minimize noise and interference for single sideband reception? A, 500 hertz.
B, 1,000 hertz.
C, 2400 hertz.
Or D, 5,000 hertz. Okay, so minimize noise and interference for single sideband reception. So what we want to do is, if you have some adjacent interference, then you want to kind of narrow your bandwidth.
So that you're just hearing what you
So you're
need to
just
hear.
getting down to where the business is. And 500 hertz is going to be way too narrow. We said the width is about 3 kilohertz. So I'm thinking that would be C, 2.4 or 2400 hertz would be 2.4 kilohertz. So that's going to take from 3 down to 2.4. I'm thinking that's going to be the answer. A 500 hertz is way too narrow. B is still going to be way too narrow, but you won't be quite as muffled.
Yeah, a little better.
And D, you're actually going out wider,
Yep.
almost to AM.
Yep.
So I'm going with C, 2400 hertz.
I think you're right, and that's what they're saying over here. Yeah, they're saying A would be for CW, and it probably would. It certainly wouldn't be wide enough for voice. There you go.
All right.
2400 hertz.
Which of the following is true of the use of single sideband phone in amateur bands above 50 megahertz? A, it is permitted only by holders of general class or higher license.
B, it's permitted only on repeaters.
C, it is permitted in at least some portion of all of the amateur bands above 50 megahertz.
Or D, it is permitted only on when power is limited to no more than 100 watts. That's is the wording of that last one?
Is permitted only on, yeah, I think there's a little typo in there.
Yeah, I think there's a little. These came straight from the question pool, so that's the way it is in
I think
there.
it's supposed to be is permitted only when the power is limited to no more than 100.
All right. Well, I'm going to read that one again because I really wasn't paying attention when you read it.
Okay.
Which of the following is true of the use of single sideband phone in amateur bands above 50 megahertz? So that's going to include 6 meters and everything above that. So what is true is permitted only for holders of a general class or higher license. No, strike that one because, as a technician, you can use frequencies 50 megahertz and above. You can run whatever modes are permitted. So you can use sideband. B, it is permitted only on repeaters. No. Single sideband is primarily used on simplex communications, like one station direct to another.
I've never heard of a sideband on a repeater.
Sideband repeater either. I'm not saying there's not such a thing, but I've never run across it. D, it is permitted only on when power is limited to no more than 100 watts. No, it's you're not limited to 100 watts with single sideband on frequencies above 50 megahertz. You can run, whatever the permissible power is, regardless of whether it's single sideband or, some other mode. So it's going to be C, it is permitted in at least some portion of all amateur bands above 50 megahertz.
Right, that's the one that makes sense.
That's the one that makes sense. We've got, in each of our bands, we've got at least some little slice in there that we could use single sideband modulation.
Yeah, and if you're studying for your technician license, which is what this show's about, and then you've pretty much got all the ham bands above 50 megahertz wide open to you.
Yeah, and they're saying over here in the chat room it is a trick question, but that C is really the only one that makes sense.
Yeah.
Let's see if we're all making sense. And we are.
There's a first
How
time
about
for
that?
everything.
Yep. Okay, well I got one for you, Tommy. And
All right, hit me.
we're gonna change subjects now. We're gonna talk about electronics again.
Uh-oh.
You
Can we
remember?
go back and do modulation?
No, can't do modulation. You remember last time we pulled this out?
Yeah.
Well, I'm gonna whoop it out on you again.
You are? Okay.
All right. So here we go.
I'm half asleep too, so this ought to be interesting.
All right. What formula is used to calculate current in a circuit? It's A, I equals voltage E multiplied resistance R.
B, current I equals voltage E divided by resistance R.
C, current I equals voltage E added to resistance R.
Or D, current I equals voltage E minus resistance R. Have I told you how much I hate this one's here?
Well, let's think about Ohm's law. How is Ohm's law typically stated?
Yeah.
If I ask you what's Ohm's law, what would you give me as a formula? It is getting late,
Here, it's
isn't
right
it?
here. That's what I would give you.
Yes.
Yeah. Oh, I equals E divided by R.
Yeah, it is kind of small to see there. I equals E over R. All right. This is Ohm's law. Remember we talked about if you knew the voltage and the resistance, you could divide the voltage by the resistance and it'd give you the current. Or you could take the resistance times the current and it would give you the voltage. Or you could take the voltage and divide it by the current and it would give you the resistance. Boy, this is like doing it in a mirror.
Yeah.
So, what's the answer?
A.
A. Current equals voltage multiplied by resistance. I think I heard a buzzer.
Okay, hold on. Chat room says D and B. I'm not the only one that's stuck. It's divided by. It's backwards.
No, it's not backwards.
It is up there.
No, not only if you're pointing.
I'm gonna go with the answer is B.
B. So you're saying it's
Current
B.
equals voltage divided by resistance. Yeah, that's right.
Current equals the voltage divided by the resistance. I'll go with that.
Yeah, that's right.
There you go.
I know that. I'm just in a coma.
Well, I've been wanting to use that buzzer for a long time.
Yeah, you
man.
can go ahead and use it. That's fine.
Yep, I did. I already used it.
What is the current flowing through a 100 ohm resistor connected across 200 volts? A, 20,000 amperes.
Boy, that seems like a bit much. B, 0.5 amperes.
C, 2 amperes.
Or D, 100 amperes. Well, we're going to use the old formula here. What is the current? All right, we're trying to solve for current of a 100 ohm resistor connected across 220 volts. So I've got 200 volts. I've got 200 volts. I'm going to divide that by 100 to get the current. That's going to tell me it's 2 amps. What do you think?
I think it's 2 amps.
You think it's 2 amps? I think that's what the folks in the chat room are saying. It's 2 amps. I think I deserve one after that. Not that it was particularly hard.
Hit you with the buzzer.
Well, you still got another chance or two. But before we do that, I'm going to hit you with it again.
Okay.
What is the current flowing through a 24 ohm resistor connected across 240 volts? A, 24,000 amps,
What kind of fuse you put in that? B, 0.1 amperes,
C, 10 amperes.
or D, 216 amperes?
And remember, we said, I think it was last time, draw this chart out
Get the
when you
volts
sit down.
divided by the resistance is going to be 10 amperes C.
So you're saying it's C.
So I'm saying it's C.
Well, that's what they're saying over here. Let's see if you got a buzzer. Nope.
Totally redeemed myself.
Totally redeemed yourself, yep. All right, well, let's see if I can avoid the buzz. If I did, that was the last question.
Cheater.
Nope, nope, that's just the way the cookie crumbled. So there you go. That's our questions for tonight. See you later. No, we've had a good time with you guys over in the chat room tonight. You know, whenever we're shooting,
Y'all had a lot of
college.
bonding time.
we did have a lot of bonding time before you got here. I think maybe we even got a whole different crew than we did when I started out like 3 hours ago.
We still got one of these left.
Oh, we do.
On the 15th of each month, ICOM is proud to sponsor AmateurLogic.TV with hosts George Thomas, Tommy Martin, and Peter Barrett.
This looks a little crude, but roughly here's what I have. The bottom trace here is ground.
While the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
Actually turn that into a scanner capable of tuning across a wide range of frequencies.
Whoa, okay.
What is this called?
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas via the switching matrix.
Down in Melbourne, apparently they tune up their radios different than we do, Tommy.
Oh, yeah?
Now, the FM 900 is tough. Seriously tough.
We finally arrived.
Man, we're in ham nirvana.
Again. Boy, what a great time. And as happened last year, we still haven't got all the way through the flea market yet.
No, we've hit about a fourth of it, but we're going to have to strike a trot.
Well, the moment of truth has arrived. I've attached a B and C connector to the antenna terminals here. I've got plus 12 volt in ground power coming in here. It's going to my power supply. That I'm supplying it with 13.8 volts.
And I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
Yeah,
What about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack, and went outside. The house lost power. The whole neighborhood went out for about 30 minutes. I don't know what happened.
Wow, that explains a lot.
All right, Tommy, sing the theme song here.
Welcome back to the Late Late Show with George and Tommy.
And we've got a spooky show for you tonight. No, thanks everyone for hanging with us. I know it's run extremely late. I think this was a marathon session. I don't know that I've ever sat and talked for this long ever.
This is a late session, I can tell you that.
Usually I don't say much, but
it's 12:30 in the morning already.
Yeah. Tommy, we got something real special here we wanted to mention, and I don't think we'll really be able to cover it like we'd like to, so we'll probably be talking about this again in the future. This came from, who did this come from?
It came from Greg, VK2TQ.
Greg McCulkin.
Yep.
He's the guy who sent us the J-Car, and I don't remember the name of that other catalog. I can see it, but I can't see it. Altronics.
Yeah.
It's those two great catalogs.
Sure did.
Boy, this one's got the transparent
this is
background too,
totally
doesn't it?
translucent.
Yeah. Here, I think we'll have to uncloak for a minute. There you go. This is your entry into amateur radio. What this is the Australian Foundation class license guide. They do it totally different there than we do it in the U.S.
Yeah, I guess that's their version of the technician.
It
license.
is.
It's their entry level license.
But it's a little different than a technician. They get some slightly different privileges. And I kind of like what they're doing on some of this. We're going to have to talk about this more in the future. But their study guide here is, it's nothing like our questions and answers. It's not like that at all. I mean, you know, they actually go into some kind of details in here. They've got explanations in here, drawings, battery safety, radiation safety.
Yeah, a lot of good stuff.
Tell you how to run a radio. It's not like our question and answer study guides whatsoever. It's
it's more like almost like a textbook.
Almost like a textbook. Some antenna projects in there. Some really good stuff. Now, I'll be honest, I have not looked at this like I want to yet. I just haven't had time to sit down with it. But I'm thinking I might could learn something out of this.
Yeah, it's pretty neat. I'm looking forward to looking at it too.
Tells you how to make a contact. You know, we're going to have to get Peter on this show sometime. I don't want to confuse, you know, the amateurs or people studying here in the U.S., but it would be good to see, you know, get a little different perspective on it, you know, on how it's done in other countries.
Yeah, but I appreciate you sending that stuff, Greg. It's pretty nice. It's very interesting.
It's very interesting, and we'll visit this at some point in the future, talk a little more about it. I imagine there's some material in here that would even be beneficial for our audience.
Probably so.
Yeah. Well, thanks for being here tonight, everyone. We appreciate you hanging with us. And Tommy, why don't we get together and do this again next month?
All right, let's do it.
And our winner is Jim Dawsey, KM4SUI, and he said, what did he say? Thanks, George. Oh no, this is last month's winner.
Okay, let's do that all over again.
All right, well, I'll just draw it.